were seeing the In Search Of programs when they first came out, and we had taken quite a few vacations into Upper Canada and BC and all that, and so I was very familiar with all this, but I was also familiar with there was a reality that was not being shown to us, and that was from a very, very young age. That's what actually led me into the historical research and things about the histories we're not being taught. And that bridges now into the realities of the biology we're not being taught, and we're wondering why. So as I grew older, I actually expected to, at some point or another, learn about the people in the academia or that circle at some point or another, which I assumed was taking this serious, and they apparently were. So as I stated, in 2010, I decided to go ahead and focus a little bit of our research techniques, our tactics in the field, which is always stealthy and strategic in our own nature. Doing the work we do can be quite dangerous. Other human beings would like to eliminate you off some of these things. And so we wrestled with that. So we applied the full mentality and methodology into the Bigfoot subject, mainly just to bring about to the people the reality that we were already aware of. Also doing the high-end research and recovery work, we were affiliated with a lot of backdoor agencies and a lot of covert operations. So having that background and that nature brought me into a lot of answers and a lot of information that most people just weren't privy to. Because we encountered many types of scientists, from environmental scientists, biologists, to geologists, archaeologists, anthropologists, and all these people were involved in one aspect or another of our research and studies. So I had the opportunity, the rare opportunity, to be in the middle of nowhere and have hour upon hour to share and to have shared many, many facts and fallacies both about this species. And of course, I had no outlet to show anybody or tell anybody, so the frustration grew deeper. So in late 2010, I went ahead and produced a video, which YouTube has since removed, even though it had outstanding ratings. And it was about when we had filmed in 1995 while on a recovery operation. That video, I don't have time tonight to show the video itself, but that video is available on our channel on YouTube. You guys can get information on that. It's Critter Exploration, YouTube. And that one is called, it's 1995, I think, in the title Bigfoot. And it's only a minute 45 seconds long. And we just didn't have any more time at that moment to film it, because it stood there and it didn't go anywhere. And we have a skyline about half a mile away. And with the early digital cameras of some of the first GVC stuff, with massive zoom capability, it was actually only 12 power zoom and 10 power. 12 optical, 10 digital. So you're really, you're just looking at a 12-power optical zoom. But we were able to capture the individual in such a manner, and that he was revealed to us from just below the waist or crotch cup. And seeing over ridgeline at even a half-mile distant, he was huge, absolutely huge. He stood out like a sore thumb. We were in partial denial about what we were looking at, and in order to continue on the operation we were on, which we weren't supposed to be where we were, we had to leave and let it be as it was. And a little while later, we enhanced the video using an early what they call snappy software when it was released, but it was a CIA digital manipulation enhancement software that I had used in previous times to even for convictions in a couple of court cases by rebuilding imagery. So I took that same snappy system and I applied it to the video that we shot at that time, and we came to realize, oh my gosh, it's exactly what we thought it was. We were able to identify depth of feature. So depth of feature based on contrast now is easy. Back in those days, it was completely manual. But it allowed us to map the overall contours of the body, the depth of the eyes, the protrusion of the mouth, the nose, even a half mile. So that reality became, as I say, very real. And I came in 2010 and I produced that, and I let it go to the public, even though we'd had the video since 95. The response was pretty good. And it also the effect seemed to threaten a lot of the established powers that be and people in what you would call the early Bigfoot community, as it was growing and firing up. I'm sure most of us remember that time around 2010, 2011. And as we did this, we realized, wow, we're in a completely different avenue than apparently anyone else. And this avenue has made us, in a sense, privileged. And not only that, but our locations. So we already knew of these locations that had a high propensity to have these creatures in it, and which locations would have the best opportunity to gain the type of evidence that would clarify a lot of the understandings. So we began to conduct actual operations. We were successful enough that we attracted the attention of Oxford University and Museums of Zoology was in Switzerland, LODC, so we ended up cooperating in that as well. And then we were approached by the University of New Mexico, Gallup, to do a full year-long study on the species itself. This isn't trying to go out and trying to find the species, trying to encounter the species whatsoever. It's merely a scientific examination of the habitat and the apparent through evidence habits of the creatures themselves without any inflection. We don't put anything into this. The reason I go through this right now as this introduction is because each thing you'll see, these are all small tidbits, because this is, of course, a very compressed presentation. But each thing you see was gleaned through many years and hundreds of examples of repeating process. So what we mean by that is that when we assume, or before we form a conclusion based on technical assumption, evidence speaks for itself. And through repetition after a while, just like all sciences, we lay that down as not necessarily a fact, but this is the propensity. This is the formed conclusion based on the evidence itself. So what I present to you this evening on Bigfoot and ecology and behavior is based off of years and years and years of in-depth understanding. Now, being in New Mexico, it's a very large region. We go from low desert all the way to alpine glacier. So we have a lot of lakes above 12,000 foot. We have a tremendous amount of diversity. Most of the evidence you'll see this evening comes from a family unit we identify as GLST, and that's an acronym for the area which we study. And we give that out to do it that way so people, as they see this information from different areas, can recognize this information. So this family unit that occupies this zone is limited in their travel. Now, they didn't show up into this zone until about 2010, when another area about 30 miles away burned heavily. And we had U.S. Forest Service friends up there, and they had some really bad encounters with these creatures, doing everything, even entering homes. And I'll tell you a quick story. So it pushed so far, comes from a USFS ranger from that area that I talked to, and he was very open about this. He said that there was a young subject who we actually believe we tracked later on and identified, and he has a similar habits to this even in the new location, but he had entered a home, and a young girl, like 14, 16, young girl, had seen it in the house, where it actually opened the door, went in quad, it was pretty big, and it started going through the house, and her bedroom was at the end of the hall. She rose up and looked at it, saw her, and it just moved back out of the house. It didn't do anything wrong, it didn't do anything to her. But the simple fact that it had become so brazen as to enter a home pushed the USFS over the edge. This wasn't gonna happen. So they quickly went and utilized, out of Colorado, I believe, they got what they call a Kodiak trap. So this is a bear trap made out of a 2,200-pound piece of steel culvert, incredibly tough material, and it's about 6 foot in diameter, and it has a gate on each end, and it's open until the animal enters, and they press a pressure pad, and both gates fall. So they set it out in the evening, one evening before they got off work, 5 o'clock. And the man told me, he said, the next morning I was driving back into work to the field office. He said, we drive by that location and we put it in a place we could see it way down the valley. As he's drawing, he just took a glance over. He expected it to be there, complete, of course, because they just dropped it the evening before and the trap was gone. So this is a 2,200-pound large Kodiak trap, built to trap 2,000, 2,500-pound animals at max. I mean, nothing gets out of these things. So at that time, he progressed on to the field office, and in which time he asked his cohorts, basically, why'd you guys pull the trap? We just sent it out there. Well, who pulled it? Because one, we're off, no one's been on, and it's already gone. So they told him, what do you mean it's gone? We didn't even look, And so they all got together, and they went back out there, and they looked. And sure enough, the trap was gone. In its place was a lot of disturbance and tracks. And what they did was there was a small creek, so they had put this in the back of a valley where a small creek entered the valley in the open grass, and everything else is really, really dense conifer, so real dense pine forest with a lot of low scrub. So as it goes, they entered the area and they saw a lot of marks leading off, but they didn't see drag marks from the trap. So this is kind of important. This is 2,200 pounds. So they follow the tracks and the disturbances, and he said it was intermittent. Sometimes they'd lose it and get it back, but it followed the little stream bed up. So they went up about a quarter of a mile into a dense, very pocketed, little tight canyon, very treed, and they said they broke through and there was a small clearing, and there was their trap. It wasn't together anymore. Both ends had been ripped off of the trap. These were welded on steel ends. Both ends had been ripped completely off of it, and the trap itself, the 6-foot culvert, had been smashed flat. He said like a bulldozer ran over it. And that was it. They quit trying. That was it. They were outclassed, they were done. And this is USFS. It was more like, well, if they do something, we'll handle it then. If not, we're overpowered, we can't handle this. So, and he told me it really flabbergasted everybody in there. Well, 2 years later, I think that was in 2008, early 2008, I believe. In early 2010, that entire section of the forest caught fire and burned. So he was not active in that area after that point. So he had left that area and gone to a new area in between there. So he had no more information on any situation after that fire, and so neither did I. But in the area we happened to have been living at that time, things started to happen. People started to see things. They would not tell each other because the way the public and the population is up there would have just met with scoffing, and everyone's very pretentious, this and that, and it would have just been ridiculous, and nobody wanted to suffer that, so they didn't tell anybody. But as we started to get a couple of calls in, they found out who to tell. Basically, everyone started to call us and say, hey. Now, I noticed that we went back in time a little bit, started to talk to people. No evidence had showed up before that. This river system, the reason I bring this up, this river system in which they apparently, I'm not sure it's the same group, migrated to, is very remote, but at the same time it goes through occupied, but a couple occupied cities within about 20 miles, as close as they get. And there's some other rural habitation. The riverbed itself we are very privileged. It's like a blessing. It's a piece of heaven because it's what's called a riparian zone. So you have a lush, forested, dense growth, high life content zone in the middle of a basically semi-arid grass plains between mountain ranges. So there was really nowhere to go. It's an excellent environment. No one goes in there. Even the Army Corps of Engineers and Department of Energy locked down a bunch of it, made it absolutely no access. Of course, that's if you don't cross the fence. So we began to do heavy research, and therein discovered that this family unit was occupying about a 20-mile stretch altogether, but generally they were in the last 10 miles downstream before this land in a culvert situation way down and other habitation and roads and things. And so as we go through this, the reason we had and could gain such an understanding at this piece of property is because, like I said, they couldn't leave. If they did, it would be a sort of a migration out, and regionally, it would have to be establish a new area that a family unit could occupy, get a consistent food sources, and not be harassed or seen. And so they stayed. And so we were able to study them at close range, in depth, for about 6 years. And this has been, now it's a total of course, that was 2010, we started that 2011, and now we're already in 2021. So we're on a 10-year history with this family. Like I said, the first 6 years were quite in depth. We have had encounters with them of all sorts and all kinds, including sightings, video, photographs. I'm going to refer, since we can't play video directly through this system, I'm going to refer you again to our channel. We have quite a bit of things posted as far as videos, including me surprising the large male. After 4 years of searching for his tracks, we found his tracks the first time. The next day I went in alone and surprised him awake and stayed in with him at 57 feet. And he's 23-inch feet and broad daylight, and surprised him awake. He wasn't happy about it, and I stayed in there for about an hour and 45 minutes with him, as close as 30 to 40 feet. Got him on video at 40 feet, peeking over and looking at the camera. And was about 10 foot tall, and when he turned, as I turned, he raises up another foot or two. So total height, we're not sure, but based on the angle and looking at a tree stump stuff, we scaled him behind him. It's 11 plus at 23-inch feet. The female of this group has 20-inch feet, and she's 10 foot tall. We have survey scaled her before. So starting with that, you'll have a little bit of background. As I discuss behavior, this is not conjecture. So whatever I tell you came to us through evidence, and it came not through one source of evidence, one location for evidence, or one occurrence, but through many, many of these and many separate locations to validate this research. So what we do is we take the understanding that we glean from one area and we do it through repetition and predictable results. So we go in and predict their behavior and predict where they will be, and we're 80% accurate at doing this. So we've also taken this 200 miles in south and north and had the same results. Then we took it 300 miles to the west in the Chuska, the Navajo Rest, had the same results. So, and then we took it to Utah, off the borders of Skinwalker Ranch. We got invited up there to do research in the area just off the border of Skinwalker. Same thing, applied the same techniques, looked for the same sign, found the same evidence. We're able to track the subject in one day and recover knuckle prints, feet print, hair, foliage manipulation. So all these things just by one day. So this isn't luck that established this. It doesn't make us any better or worse than anybody else. It just makes us more privileged and we paid attention. Some of the things I want to share with you, I hope that those of you that are field researchers can glean from this information and become more successful. Looking at the reality of the species, they are highly predictable in some natures. And when you understand those natures or the way they do things, your research success goes up significantly. So let's just go ahead and get right in this so it doesn't take all night. Our first slide, of course, is our introduction slide, and the print you see on the far left there was out on the table. So it scales with the other prints at about 22 to 23 inch. This came from the Sandia Mountain Ranges, and that's the picture you can see on the far right. This is just above Albuquerque, New Mexico. The bottom of that mountain there is 4,500 foot. The top is in excess of 10,000. So we have cliff faces over 3,000 foot tall. It's extremely rugged and chopped up. There are no trails up there. No one is allowed at night on the entire mountain range. They have it locked down. USFS told me up to 30 people have gone missing in 1 year off one trail with no criminal investigation whatsoever. So this is a dangerous region as well. Now, there was some activity happening in a very affluent housing district up there about the time that Oxford University contacted us, and they wanted some specimens. And we were able to give them one specimen we already had from the backside, and then they wanted something off a living species. If we couldn't collect it directly, collect it in the presence of fresh evidence. So it took 2 months to do this, and they held the study. This is Oxford. If any of you remember the OLCHP, the Oxford Lausanne Collateral Humbling Project, the results for that was supposed to come out in February. Okay, and so they held, and that was the final study stuff. They held the study itself for 2 months waiting for a specific sample. And there's a reason I go into all this, and we'll dip into it here in the near future in this presentation. But needless to say, we supplied that evidence with a lot of corroborating evidence in the presence of professionals, USFS and anthropologists. So the pictures you see are representative of those, and they as well gave us a lot of understanding and a lot of interference, and we learned a lot more about people, the science, than we did the Bigfoot through these endeavors. So let's get right into it. So we're going to examine ecology. First, we'll start with a quote, I guess, from Sir Conan Doyle. When you have eliminated the impossible, whatever remains, however improbable, must be truth. And there's a lot of logic to this. Because, yes, things could be bear. Yes, things could be mountain lion. Yes, things could be hoaxers. But you know what? Some things cannot. Some things cannot be any of those things. These are where we find our truth, because these are the kernels that will lead us to understanding. But if we factor in the knowns, right, into our research, it deludes us a little bit. Clarification comes from taking those things that we don't know and trying to understand them. Then that gives more light on what we do know. Now we're going to start with ecology, and the first section is going to be diet. People say, what are the foods these creatures can eat? They'll certainly have to sustain a massive body and a big population on this. So the biologists run through and think, okay, I'm going to assess all the food sources in here. But you have to understand, this is inflection again. This is what people put into it. What would I assume that a Bigfoot would eat? Okay, so we're going to concentrate not more on, we'll do some substance, but we're also going to visit a couple of the more obscure things that they'll feed upon. And what this will do is show you that biology seldom factors in all the possibilities. Because some of these possibilities, they would not factor in. Okay, so let's progress. First thing in diet is a subsistence food. It's called Russian olive. Now, this is an invasive species of plant that coats a lot of the northern continent, and it covers a dramatic latitude. So we can find this stuff from the Mexican border all the way up to northern Utah and above. This is prolific. It's a problem. They try to get rid of it because it grows so fast and it's so invasive. But what they don't discuss with you is the food source that's available off this plant. The tree itself produces massive, and I mean massive amounts of the small berry you see on the screen. On the left-hand side, you'll see the actual tree, and in that little picture, there's actually some broken branches that are Bigfoot sign. And these are what we track them by. So we over the years, 10 years, we've gleaned not just what is sign of them, but as well what a lot of this means. And so we've been able to read it the same way they read it and have the same results, like finding a group. Okay, so they will mark these food areas, and they'll also mark the zones in which they're traveling through them. And they do it in almost a neurotic process. We'll get into that here in a minute as well. So our next slide is another food source. This is called pinon, or pine nut. This is prolific, of course, throughout the entire Southwest, and it grows in many different types of habitats. So it'll grow in the broad valleys, it'll grow in the dry arroyos, it'll grow up on the high mountains, and it'll grow almost up to 8,000 or 9,000, 10,000 foot. And it's a tremendous food source, and it's year-round. So both of the Russian olive and the pine nut are year-round available foods. Now, pine nut especially is difficult for bear and other things to eat. Well, mainly, you're talking the bear in hibernation times. But any time it's snow or there's anything covering the ground, a bear has a very hard time trying to feed on pinon nut because it takes a good dexterity to remove these from the ground mass and from the other material. Okay, feeding by mouth is not very productive with this type of food source, even though they do it. Bigfoots, on the other hand, will sweep away the snow and just pick these things out. Now, we have found scat near collection piles, near structures associated with tracks that represented up to 15 pounds of feeding of pinon nuts between defecation periods. Now that's a lot, because these things have a shell fragment, husk, and this shell husk is very, very sharp, and it's very, very durable. So it passes through the animal complete. It would cause gastrointestinal or gastronomic distress, and it would cause intestinal distress if you or I were to consume those much shells and try to pass them. But we noticed this is a subsistence food. This is what they're subsiding on, because hunting is one thing. Hunting is not always successful. Family units cannot hunt to feed their group. They need to have constant forage in order to do this. So if you want to know zones where family habitation occurs, it's going to be occur in an area where there's a reliable, constant source of food, regardless of what it might be. So the next slide, we're going to see algae and greens. So these are something that's very taken for granted as a food source. Algae, prolific. They eat it all the time, either as a small supplement or in really bad winter conditions where they can find warmer water situations where there's still algal growth. They'll consume just that and sand. And so you'll find fecal material where the entire scat is sand, and it has the green hue from chlorophyll from eating the algae. And so that's another thing. They think they know what they would eat. And I'll tell you, they're similar to humans. They will eat anything if they get hungry enough. Absolutely anything. And it's amazing what they can stomach. Here we have another prolific constant food source for them, and that's birds. So in this picture, in this picture we see a pile of plucked feathers. And what we're seeing is the aftermath of the type of bird that's on the left, which is a woodpecker. They're commonly feed on woodpecker, and we find that a lot. And why? It makes sense. Woodpeckers build nests inside burrows and trees. They're very easy to harvest. If you know which hole has a woodpecker in it, he's fodder. He can't go anywhere. And what we see is they'll put 2 fingers into the hole in the tree. They'll literally just pop out the side of the tree to access the woodpecker. Even really healthy pine, they can just reach right in there and pop it out. And then they'll pluck the bird, and we never find the bird. We don't find the beak. We don't find the feet. We assume he just eats the entire thing because we never find those remnants. We also never find any blood on the feathers. The feathers are always piled basically neatly. These are dispersed even a little more than usual. So it takes kind of an anal personality to pluck and pile, pluck and pile, pluck and pile. So this tells us something about the subject that's doing this operation. And this is where we form our conclusions. Through repetition, we begin to understand the psychology as well as the habits of the individuals doing this. So that's where we get our predictive nature. Once you understand the psychology, you can predict what they're about to do, what they're going to do, or most highly likely to do. This increases your success at research. Here again is another kind of obscure food source that no biologist equates, because these berries are highly astringent. Most animals won't eat them. It's called a juniper berry. This is what they make gin from. Also called gin berries. Okay, so and the reason they make gin from is because you couldn't eat them. Because like I said, they're highly astringent. They're very, very antiseptic as well. And that's part of that astringent nature. But they consume them, and they'll consume them in great quantities when they're available, which is pretty rarely. But it does show you that when other food sources are not available, they can palate and stomach and digest foods that we would think would be so hardcore in the system that they would avoid it entirely. So it's another food source not equated. Here's another one. This is called yucca. And this plant, of course, grows across the entire southwestern United States. It grows all the way up into Utah. And you can see a harvested section of leaf here. And what you'll do is you'll find where they've been grazing out an area, and they'll rip the leaves loose from the yucca, which isn't easy in itself. And then they'll bite the bases off. Now we know from past history, Native Americans would do this too when food sources were low. They would take that section, they would pound it with a rock, and they would get that little bit of mash and add it up and eat it. It's too durable for us to ever even bite through. You can't bite through a yucca. We cannot do that. The fibers in yucca are so tough they made sandals out of them for thousands of years, and they're extremely durable. Yucca rope won't stretch. So what you see on that picture, though, you see a curved area at the rib mark, and that's actually a bite mark. So this material is one of the materials we look for bite impressions. So we might find 1,500 or 2,000 examples of this in one study for this type of food source. So when we go into an area they've been feeding, that's how many of these we may find. Every one of them has a bite impression. So we get to see the size of each individual that's been consuming this by scaling off the teeth. In general nature, the larger or the adults have a tooth about twice as big as you or I do, which scales effectively throughout the entire morphology. So we're looking at about a 1/2 inch wide bite mark here. And to show you another expected food, okay, but with also bite remains in it, is this is a cow bone. Now, the most unique part about this cow bone isn't the scrape marks, and it's not its placement or anything else. It's that there's not another tooth mark on it from anything, from a rat, which go for calcium, and they go for that stuff on bones. Coyotes, same thing, or anything else. There's no marks on this whatsoever, but it was completely fleshed, which is interesting too. Okay, so there's insects, there's ants and things that can do that, but what they can't do is the scrape marks you can see on the right-hand photo. Those are the same impression marks. Of course, this subject is 300 to 400 miles from the last example, yet we see the exact same dentin marks in this bone, which is a 1/2 inch wide bicuspid scrape. And then if on the extreme right of that picture, you'll notice a crushed edge right at the silver tip of the tape measure. You can see the breaks in the bone there. That's because they bit off that entire section of where the cartilage and the tendons and ligament all joined this bone. So they consumed that cartilage. So they scraped the top as they bit, and they bit completely through that side and then threw the bone down after it was fleshed. The only thing we see done to these particular types of bones and things beyond this is when they will crack them open. And they don't even have an impact mark. It's like they can just literally grab that bone and break it, which I know if you ever tried this, it's not going to happen. Immense strength and enough to put enough power into a small zone to break it, but that's to get the marrow out, which they don't always do. It seems they do it when there's less food available. Another extremely obscure food source that we've noted is porcupine. Now, there's something you're not going to think of as a food source. Coyotes don't normally eat porcupine because if they get porcupine, they're not like dogs, they realize that could be life or death for a coyote. There's no vet to run to get them out. Porcupines have been around and been successful throughout the years because of that ability. they get left alone. But as you can see the scat on the right-hand side, the animal not only consumed porcupine, but passed the quills. Now that's pretty rough. There's not a lot of creatures that can consume the skin and quills of a porcupine and then pass them through the digestive system. This is hardcore stuff. Now, if it was a coyote, those wouldn't be whole either. You're talking, you can see the end of my thumb. We're talking about quills that they're a little bit decomposed from the acids, but they're still in excess of 2 inches long. And you can see in the picture of the porcupine there, his quills run anywhere from 2.5 to 4 inch. So this subject ate a porcupine. Okay, so biologists don't factor this stuff. So when we tend to this argument about, oh, well, they couldn't live there because there's just not enough food resource, what are you talking about? Is there something alive? Is there something that they can scrape up? Because they're going to eat it. And when you're this way, an omnivore can procure enough food to survive and have plenty. And so we're not factoring everything in. Another thing that we'd probably expect are grubbed logs. Now we all kind of think, yeah, bears do this and cool. It's hard to tell which is which. Well, there's certain forms of evidence that you can declare and find out what did this. Like in this log that's been torn into here. Now they're doing this to access beetles and grubs, so we understand that. It's conjecture still, but we understand that would be the focus of your opportunistic behavior here. But they're also eating something else that we're not aware of, or most people are not. So we've found that they will consume the pine dust. So as the grub goes through the log and grows on the pine material, the excrement has been processed biologically through the grub. They use that excrement or that pine dust that fills those holes, they'll eat it. I'm sure anyone that's been in the field has probably found this before. And they will consume that material. And I've not done the research to find out what occurs between when the grub gets it and what it does for food value, if it makes it absorbable or not, but they will consume it. Another neat thing about this particular site is for when we had tracks, like I said, everything has corresponding evidence. So I'm not showing you anything that didn't have one or another form of corresponding evidence, normally being tracks. So this is all had tracks leading around the area into it. But you'll see there's an absence of claw marks, teeth marks, or anything whatsoever. The side of the log has not been dug out, but yet the top of the log has been removed. Some of the sections were even placed on the log itself. There's one barely visible to the left side of the dig mark in the log. There's a piece sitting there. Well, the bear didn't pick it up and place it over and put it down. They dig through things, they claw things, they want to get it out of the way. They don't care where it goes. They don't bother trying to place a piece of wood. So there's a lot of indicators here that it was not a bear. And that takes us back to the first quote by Sir Conan Doyle, does not. Because if it's not a bear doing this, then what is it? And then we have the high likelihood, if we have all the other indicators of a massive species such as this, that's our most likely culprit. We have to actually reach outside of common logic to assume it's anything else at this point. So now it takes us into method. So we say, do they use tools, and is there any evidence of them using tools? Well, yes, we have found evidence of them using tools hundreds of times. Matter of fact, because they'll just do it just haphazardly. They'll find a rodent burrow, pick up into your stick, dig out the rodent. This is a rabbit burrow in the side of a dry wash. We were tracking the individuals, following their tracks, and they led they led all over the place, kind of, but they focused on this hole, and the stick on the lower left in the lower left photo, they picked this up and they dug out probably a rabbit from the size of the burrow. Now you can't see is in the right-hand photo, you can see all the dig marks from that stick, where they widen that out. And the reason is that burrow goes in and turns to the right that you can't really see too well. And it dips down about 2 feet, and it goes about 3 feet down. I could barely reach all the way in there to get to the bottom of the hole. But they had widened it out enough for their shoulder and arm to reach into the hole and could reach farther than I could a little bit, and they would have grabbed that rabbit out of that hole. Now, I'm not sure it was a rabbit. That's my assumption. But what's not my assumption is their methodology here for using a tool to gain access to an animal that is protected. So that's tool use. The next tool use that we find very common, it's hard to discover with any credibility, is projectile use. Now I know from personal experience, they are highly accurate. Even the young individuals are extremely accurate, and they can throw in a manner that make any baseball pitcher absolutely cower. I've been hit, and we have it on video, and I got hit by a rock that weighed about 1.25 pounds. And even as the subject approached on all fours, which we got him on tape doing. We could see him in the moonlight, and then the infrared cameras picked up his eyes. And he comes around a pole and hooks it at his sidearm, and was still able to be absolutely accurate, with balancing on 3 limbs and smacking us. And it hit 2 of us, actually. It striped a guy's gut. This is my buddy Juba, one of my Navajo brothers. Striped his gut as he was raising up. It would have caught him, shot right in his side. The rock hit him, it came in hot enough to a broken arm bone. If it hit him in the head, could have killed him easily, without a problem. It hit me after it hit him, and I was bent over and had big sets of gloves. It was a 22-degree night, so I was very bundled up. We're in static positions, so we're not bouncing around, so we have to dress real warm. So I'm packed in this jacket, and I'm crouched down, so that big packing of my jacket's all built up there above my leg. And I had a large set of gloves in that pocket, and it hit that pocket. And it still hit it so hard, it sounds like a baseball coming into a catcher's mitt in a pro pitch. You're talking 80, 90 miles an hour. A 1-pound rock at 90 miles an hour is enough to cause fatal injury like that, without a question. And this was a juvenile that did this. We were in a group surrounded, some as close as 8 feet, which shows up on video. I showed up video. And the juvenile of all the subjects there, the large alpha male stayed back 100 feet, clicking his teeth like this. The younger, older males got in close to us and kind of just tried to bully us a little bit, and not bad. It was kind of play. Everything felt really good during the encounter. We were laying prone on the sand to avoid being grabbed because we were within grab distance a couple times. But a junior, about 60 feet away, I think 63 feet when measured, crept up, found a rock where there wasn't any rocks hardly. I don't know where he got it. And he crept out. We watched him creep out 2 or 3 times, and you see some video of my Navajo brothers grabbing his knife. I'm telling him, put it down. Don't even touch it. Let's just wait. And so, but I mean, that's his fear, and they don't run. They'll defend themselves from anything, which is why we use them. But needless to say, the juvenile got scared, and it got defensive, and it hit us with the rock. None of the other ones did anything about it. It hurt. I stood up, and I did what I could do and tried to stay strong and logical, and we backed out. As we did on video, it goes blurry because it's losing focus, but you can see 3 subjects step out and follow us down the road as we're backing up. Now it's full moon, we could see these subjects. But the camera just catches, the infrared camera catches their eye shine. This is, again, it's a video called MJ13 Part 2, and it was done during the University of New Mexico study. So where they had actually put us to stay the night was on a private land holding that nobody gets onto. They do custom fishing, fly fishing and things because they're on the San Juan River. It just so happened to be that we used the same techniques and the same methodology that we had gleaned off the family unit that I'm going to show you a lot of this from, and used it there, and were able to find, in 2 or 3 hours, find scat from an infant. So we knew they had an infant. We found scat from little toddlers, and then we found sign from larger individuals. When we got into camp that evening, about 10:30 at night, we're all sitting there, just winding down. We were just starting to sit around a fire. We're kicking back. All of a sudden, you hear giggling, like a child's giggling, just giggles. And then you hear a soft laugh, like, haha, like from a female voice. But this came out of some of the thickest crap you've ever seen on the other side of this river. And it was actually quite loud. And so everyone just looked around like, wow, you spotted infant scat this morning, and now we just heard an infant giggle in the brush in the middle of the dark. So we'll get back to, but so they use rocks as projectiles, as weapons, as intimidation factors, and even as part of a game. Of course, for a human being to get hit by even a small rock lobbed in can be quite hurt you. But even the playful ones will throw the rocks like this. Now the extent of this goes into large rocks for large game. So this rock weighs about 70 pounds. It's a chunk of granite. This was during the study for Oxford, Lausanne, gaining the hair sample we gained. That large print I showed you in the beginning, 23-inch print, belonged to the individual that threw this rock. His palm width, just the palm, was 8 inches wide. His hand from base of palm sprayed to top of finger was 16 inches with a 15-inch spread. Is a 10-inch wide fist. Okay, so 10 inches wide on the fist is massive. It looks incredible. The fingers themselves are an inch and a half across and even bigger. So this rock was a projectile. Now we know through evidence this is an old individual. We gleaned that because of the hair we found was 6 inches long, gray in color, aged gray. Didn't have a variegated base. So a lot of the gray-toned animals will have a color base or to the base of the hair until they age out, and then that'll turn gray. So we found that. We also found yucca fruit and a few other things that he had apparently eaten or bit into that showed a bite imprint with quite a few missing teeth. So apparently, we found yucca fruit there that were brought up from the valley about 2,000 feet below. So apparently, gleaned from the evidence, it appeared as if he was cooperative hunting with 2 individuals that had smaller feet, around 14 inches each. And they were working a deer downslope in this decomposed granite surface. And they worked, he was down lower on the edge of a little swell in the ground, so to speak. So it was kind of a little pinch point. And he was on all fours, which is where we got the handprints and stuff. And he apparently threw this rock at the deer about 15 feet away. And we could see the marks from the deer hoofs to the rock, which was laying as it should not. It was laying as it is in the right photo, and then he turned it over in the left photo. So it had landed like that right there and disturbed Earth. But it disturbed Earth on an upward trajectory, if you look at it, not down slope, which is really off the wall. But it came with force from a lower position. The deer prints stopped, and there was foliage breakage behind that. Apparently, this rock hit that deer with enough force to knock it back 4 or 5 feet, and the rock to continue its forward momentum and to land in that position. Now, I think we all understand that if a 75, 80-pound rock, even at 30 miles an hour, was to contact the side of a deer, you're getting a deer. There's nothing going to take that. It's going to collapse that entire side of that animal. So, through the evidence we've seen in this individual, that what we believe is as they get older, even the big males, they become slightly dependent back on the family unit for cooperative hunting and to provide resource. Also in this situation was a large flat rock we found, where bone had been crushed to a mash. And we assume that they were consuming basically, or he was consuming basically everything he could get that he could eat, and without having the dentation to properly eat the rougher meats and things, they were pulverizing it in the bone on a rock. So let's skip from ecology now, and we'll start moving into some of the other effects on the environment for these creatures. First being tracks. I know everybody likes tracks. So our tracks are going to be a little bit different to what you're used to on some of them. So what we see here is a juvenile, or actually is even younger, probably a toddler. Still pretty considerable size, about the size of maybe a 10-year-old human, maybe a little older. And what he's doing here is, as you can see, he's moving on his hands, or his fists, and his knees. And so he's putting his fist to his side and scooting forward and picking himself up, putting his fist back down. But at the top of the photo, what you'll notice is these marks completely stop. And what happened was, next to this soft sand, you have a small drop-off to a harder, gravelly surface. And apparently, a larger subject, because he didn't fly, and we did find scuffing, but we couldn't find any good tracks on the hard surface. And this is the thing with the large individuals. They don't like to leave sign. This has been more than obviously demonstrated to us throughout time. The large individual reached over, and it's probably 7 feet, or 6 to 7 feet into the soft sand, and snatched this smaller guy straight up out of the sand. So what you're seeing is an expression of the younger individual doing what kids do, going to play in the soft sand, going to make some marks, and a larger individual grabbing them out of that position and removing them from that position. Now we see this repeatedly, and sometimes it gives us our best chance to get evidence. Out on the tables, we had a track that was a double set of track. The track stepped right back in his own print. And what that was a smaller individual ran with it was 6 inch foot, 6.5 inch foot, ran out into the riverbed out of the thorns and stuff, and a larger individual had to get him. But in order to do so, he had to take 2 steps out into the mud, turn around, take 2 steps back. And he was trying to avoid leaving prints to the extent that he stepped in his own prints coming back, literally placed them directly back in his own prints, which is why we have a double track, one over the other. Okay, so, but what it told us was they're stopping them from running around, leaving tracks and substrate that takes the mark. So it doesn't take many times for an adult to grab you up when you start doing this before you learn, hey, I'm not supposed to be out there running around on this stuff for whatever reason. And so we see this established over and over and over, where the children or the youngers screw up, and the adults have to reveal themselves to step out and deal with the way they've screwed up, which is good for us. This is photograph of, on the right, is it's a little bit blurry, I'm sorry for that. This is the smallest print we've ever pulled. This is after we assumed by the male's behavior and the family unit behavior that they had had a birth. Plus we found feces from a lactating mother. Because of, it's a blue color, bluish green color from the breast milk. So we had found small feces along in the cells that they habitate. And so we assumed that they had an infant. Not long, and the big male had become extremely aggressive. We recorded him killing a large dog, and then we had reports of him basically killing dogs around the area at that time. So he'd become aggressive and defensive, and he was staying around the family unit a little more. So just after that, not too long, maybe 3 or 4 months, we went in and were able to find a print, I guess, where mom had set kid down just for a minute or two. But the depth at which this little print went in is considerable. It's considerable. This is tough stuff to push in. These are rocks inside of a clay surface. A dog or whatever can run right across this. You don't see a mark at all. It won't leave a print in this. So it leads us to believe they're quite heavy for the square footage or the square inch of the foot. So the surface area of the foot, they've got a lot of weight down on the surface area, even at that small of a size. This print is 4 1/4 inches. Like I said, we assume this is infant, maybe 3 to 4 months old. The pic on the lower left there is the same subject about a year later. And they're not much bigger. They haven't gone, or no, maybe it's 6 months later, but they haven't grown a whole lot. It's grown by, at this point, maybe 3/4 of an inch. So at this point, it's about 5 inches long. So the same individual, the same little guy, this is later. This is a few more months, almost a year probably. And he's now 6 inches long with a hyper-exaggerated big toe. Now this is something that all our early casts of the young individuals all show a massive great toe. So the first metatarsal seems scaled up of what it should be. Matter of fact, it's not quite half the length of the foot in the smallest individuals, which is crazy. But this foot is, that toe, that great toe is a major feature, and it becomes important when we realize the morphology of the foot and the locomotion. We're told a lot of things about these creatures. We're told that their tracks don't have arches. They can absolutely have an arch. But they can just as well be bent in a posterior position, which is backwards, just as much as forward. They can produce that arch just by flexing and bending their foot. So sometimes they'll make a mid-tarsal break mark, and it's obvious because it's a kick where you pinch that soil and we go, oh, that's a mid-tarsal break. And then we'll see where they put their foot down cupped a little sideways and look like an arch and say, oh, no, that's a human. This is something we can't take for granted. The foot, I've got pictures of the same foot on absolutely flat. Everyone swore that's a Bigfoot print. I put up a control picture and I said, is this? And everyone said, no, absolutely not. That's a human print. What those people didn't realize is these are the same subject in the same trackway, less than 20 feet apart on the same surface. In one track, left one that everyone swears was a Bigfoot. In the next, left one that everyone swears wasn't and had to be human. So testing that perception, we realized that, wow, people really need to understand how the foot works if they're going to be out there doing this. Because what if you got a researcher and he's found tracks, and because of what's been said to him or told to him by people that he believes and trusts, he says, well, no, those are human tracks. I'm just going to disregard them. Well, he's doing that for the wrong reasons. There's a certain morphology to the foot that doesn't match any human alive that we've been able to find anywhere. And that's where these bones are placed so they can have direct forward locomotion. Here's another track of a juvenile 8 inches, and both of these are. Now, you can see the difference in the 2 feet. These two subjects were together. So the lower left looks like a very robust foot. It's quite technical in nature. In other words, it's pretty dramatic about its morphology and its placement, and each of the things are very robust in nature that you see. You also see the full mid-tarsal break lifting the soil in between. Now look at the track on the right. It's absolutely flat. But what you're going to notice is if you look at the scale of the great toe and the scale of the rest of the foot, the entire first metatarsal is greatly exaggerated over what a standard human would be. Now, we've also heard that people are nervous or whatever when you have a thin heel. Some of these subjects have feet a lot like this, and we don't know why. And it gives kind of a triangular shape that we regard to the foot. and it's because the heel is so narrow. But as you can see, there's zero arch apparent in that track. There's nothing. So everyone said, oh yeah, that's a Bigfoot print. Well, that same foot can leave an arch track 3 steps later, or any other. So they're hyper flexible. The entire the small toe, the 5th metatarsal, can deflect up and down, like in a sense the edge of your hand does. So the same way our hand flexes in between itself, their feet can do that. They can displace the entire 1st metatarsal, or great toe, and the bone structure. They can displace it up the same way you can your thumb. Exactly the same. So this gives a huge diversity in the ability of a foot, the way it's on the substrate, to leave a track. This is 2 young, 9-inch and 11-inch. So you can see in the top print on the right-hand photo, you see where that's absolutely flat. You can even see dermal patterning in that a human never would have left a dermal imprint in the sand. The sand's too coarse. You have to have a really, really coarse and abrasive dermal ridging to leave a dermal imprint. The sand on the lower left is the same trackway, and what you can see in the right-hand upper track, in the lower left photo, is that large great toe bent down and deflected down below the foot. It almost looks like you're looking at a hand. Of course, its overall shape is a foot, but its flexibility is similar to a hand, more so than a modern human for sure. This is a juvenile at 9-inch. And what you see in the right-hand photo, if you look closely, in about the mid-area of the foot on the right-hand side of it, you'll see the macrodermal pattern, which is based on a circular structure right there inside the 5th metatarsal. We see this as a commonality in most of their feet, share this dermal circle or pattern. On the left-hand side is the same juvenile after you took a couple more steps, and it's the same one that we had shown before, but just in an older stage. Now we're going to go ahead and just go up. So this is an adolescent, what we call at 10-inch feet, we go to adolescent. So an adolescent, this is a 10-inch foot, and you can see on the right, it's got the lift from the mid-tarsal break. You can see the step gap on the picture on the left, and that step gap is right at 4.5 feet. Again, this is a 13-inch adolescent track, and you can again make out the curve on the right-hand photo, you can make out that sweepy curve to the mid-tarsal break and the toe ridges, and where the toes had gone down and bent back up. And so we're looking at a 14-inch foot that's actually bent 2 directions at the same time. On the left-hand side, you get a 14-inch foot that appears to have an arch. You can see a quarter laying next to it. This is interesting. It doesn't have an arch. If you actually look at the mud surface, you can see dermal ridge. I know it's probably bad, but you can see dermal ridging just in front of the heel where the mud looks intact. What you're seeing here is where the mud stuck on the foot and some of it did not. So in that portion of the foot that did not compress as hard, it released. In the press that had more pressure, the mud pulled away from the surface. Well, as we look, it looks like it has an arch, but it doesn't. It's actually fully was in contact, just a lighter surface on that foot. So this is what we call a young adult. So when the males, I'll go over this a little bit more here in the presentation, but the males often at a certain age are found alone, usually not too far away from a family unit, but away. This is one of those examples. And you can see here in the lower left photo, you have a 17-inch track, and then that's my boot print next to it. So it's a pretty big boy. And in the right-hand photo, you can see a series of 3 of these prints approaching the lower part of the frame. And if you look closely, you'll notice there's rabbit tracks. He's tracking a rabbit, and we know he's tracking the rabbit after the fact because he steps on the rabbit tracks. So he's actually moving when slight blowing snow and tracking a rabbit. Now this came as a result of a witness encounter where someone saw the Bigfoot run across the road quad on all 4s, and he said it was stretched and pulling like a big cat when a big cat's in acceleration. So that huge back undulation, pulling at the ground, not just running on the ground, but literally pulling and pushing on that ground, similar to the way a big cat does. And then we went and investigated the area. There was nothing at that time. The next weekend we went back and it was all covered in snow, and here we go with these 17 inches. Now we put a game cam out on this deal. We learned a lot about game cams and Bigfoot. This subject identified the camera, which we concealed pretty well. We even ran the area a little so we didn't think we were being observed. Did it really, really well. He identified the camera and figured out about where he was safe with it, where he wouldn't be in the emission of light, which told us verbatim he knows where the light's at. So when he would trigger this, I mean, these are probably 550 nanometer red light or infrared light. I can see that glow myself. I I can still see 850, 940, not so much. So this is a 550 nanometer camera, so if I could see it, he could see it. But he would have done is approach the edge of the frame in the field of view and balled up a big handful of snow. And during one of our videos caught on the camera, he chucks a snowball or chucks a big chunk of snow into the frame. Comes out of nowhere, out of the brush. Right? It's like 2:30 in the morning, middle of nowhere, after a witness encounter. And here's this thing messing with the camera. When we went and retrieved camera, we saw the tracks. And they approached from downhill. They got kind of to the edge of the zone that the camera could take, the trigger zone. But the cameras will often trigger slightly because they're trying to catch an animal moving in. So they'll trigger outside what their light source will film. They'll trigger outside what their own frame will film. So he's triggering that light from off camera and not moving into the light. But not understanding or whatever reason, I don't know why, he had balled up snow and thrown it into that light circle or light source. And we got that video. That's all we got. I mean, what do you do with that? Because I could say, here's a video of snow flying in the camera. Okay, so this is the alpha female of the GLST group. We've tracked her dozens and dozens of times. We photographed her and everything else. We've been really close to her. Had her grunt and scare off an Animal Planet film crew, probably 200 feet from us. And yeah, they didn't want any part of it. Once she actually made her vocalization, made her emotions known, they didn't want any part of that whatsoever. They wanted to get out of there. But you can see in the lower left-hand photo, the top print is my boot. The bottom print is her foot. 20 inches long. The photo on the right is in comparison. That's the person next to these same 20-inch prints. Of course, this is several miles away. This is where she left the river system and came back into the river system. And she left her track. We have 20-inch prints down this slope that you can see. And it's pretty controlled. It's hard to walk in this type of loose shale material without displacing it laterally to a large degree. And she's actually penetrating very, very deep in this without kicking much out, which takes a lot of finesse. It's not just slopping down the hill. A lot of control and weight to do that. This is the alpha male's print, which took 4 years to glean. So we'd seen hundreds and hundreds of track sets, thousands collectively of tracks over the years, but it took 4 years to find a single print of this large male. This is the one where I went in by myself the next day after we had found his initial print and spooked him awake, and which is how I got the print on the lower left. You can see the heels to the left, the toes are to the right, and that's a 23-inch print. And there was a whole series of those going through. He had gone quad, busted through all this stuff. If you ever get a chance to watch the video, you can hear him. It's readily available. He's right there busting stuff right in front of you. But when he had turned and gone around the back side of this thing, this is where he stepped. And so there was 3 really good bipedal steps there before he dropped back quad again. And this is when I stayed in with an hour and 45 minutes with. And at this time, this photograph was taken, it was maybe 3 or 4 minutes old. And on the right side, you see where, now that during this 4 year, I gotta say, I never found any prints in the dirt. This is the only thing he ever did in that 4 years that I was able to find. So the ground outside this was hyper-frozen. You're not gonna mark it. This ice was 3 to 4 inches thick altogether. And he had stepped, now there's a little bit of melt out, but he had stepped in one place and broke through that ice and then took 2 hops to get out. The last one's 12 feet. You can see that's a 7-foot stick laying there. And that step gap between those 2 steps is over 8 feet. Now, even if that was a coyote, the coyote would have to be running quickly to make an 8-foot leap, and he's not gonna hit the ground hard enough to bust through that much ice. Plus, we see deer and coyote prints that went by these and didn't break through anywhere on the river. And so, like I said, it probably been that night before that was below, quite a bit below freezing. And of course, to freeze the river. But the point being is the water below it almost never freezes year round. It flows a little bit. So whatever punched through this had to have considerable weight on it. And then it reacted to breaking through that ice. Like I said, for 4 years, we never found his prints. This was the best we could do until we had the actual encounter with him, in which time we had quite more than enough detail on him then. So this is going to bring us out of ecology and bring us into foliage manipulation, which we're all pretty familiar with. Our first example, of course, is going to be structures. And, you know, I'm not going to show 100 pictures of these structures because everybody's seen thousands of pictures. But what we're seeing here is, you see my buddy Zach Youngin is sitting in one of the tree structures on the right-hand photo. On the left-hand photo, you see it circled where that structure is, and in front of it, you see a smaller one. Now, this is interesting, because it's been knocked down, but the point being is, even a young Bigfoot would have a hard time getting inside that little assemblage. So it leads us to believe there's a potential or a possibility that it may also be a game holding pen. Something I don't know if everyone's considered, but you may want to trap or grab live game and put them somewhere they can't get out of, like a turkey. You could construct a small thing like this, throw a turkey in it, and if it can't get through the gap, you're going to have a turkey when you get back. He's just going to waddle around in there till you get back. So we kind of assumed, this is an assumption, we assumed that they're doing it for that reason, because they're building structures that would contain something that is too small to be utilized, next to a structure that could be utilized by an average large-sized subject. Now we got breaks and twists, so why do they do this? So, as I said, we've been able to glean after the years of what a lot of this actually means and why they do it, because we've been having the predicted results. As they travel between area to area, they will often break certain types of foliage to let the subjects that are not there with them know, apparently, where they're going or where they've been. Now, there's a couple ways they do this, and that's snapping or twisting. Twisting with the cedars and stuff like that, you'll also see that, you'll often see that inside of an occupation zone or around the perimeter of the occupation zone. And they're done a little differently. The twists inside the occupation zone are generally almost look like a flag. They're red, you can see them forever. Very, very apparent. The other forms of twists they'll do, which I'll show you in a minute, are done on the periphery. And those are done to mark an area. And it's a whole different, mark the general area. So it's a different purpose, and they repeat the same type of stuff in the same type of situations throughout these areas. So the outright snap on the lower left that's Russian olive, and that's a green branch from earlier in the year. We can't do this. I can't do it with two hands. You can't break one of these things. They're incredibly durable, and apparently they can just snap them at will. And what they'll do in an area is snap these sometimes every day or every other day on the same bush if they're occupying that immediate zone. So we're talking, well, we'll get into occupation a little more here in a minute, but we're talking pretty small areas, and as they're being there before they move on, they'll just neurotically remark and re-snap. So this is the other form of what we call signpost. So this is a scent and rub post. So when you find these, they almost always contain hair. And what they're doing is take a small, dissimilar foliage, often it's cedar where there's other deciduous trees, and they'll twist it off. And it's not, on these, they don't do it so much as to make it so apparent as the other form. And it's actually kind of hard to find it because they're not always on a travel corridor. Sometimes they are, or sometimes there's one near them, but what they almost always are is on the periphery boundary of an area, overall area that they're occupying. Okay, so, and they'll do this, and then they'll rub on the right-hand side of the stick on the right-hand photo. That whiter material you see isn't part of the hair, it's actually skin. So these are the skin cells that came out with the hair follicle. And so you've got hair follicle, hair, and skin cells on these rubbing posts, which are extremely, extremely important if we want to gather repeating DNA or repeating evidence in certain individuals and subjects. So we're able to do this pretty consistently. I think on this day we were able to find 4 of these rubbing posts and pull material off each one. So it's not uncommon once you clean this to find and recover hair. And it's also, I want to say that I can go back to this scent post today, this is 5 years ago, and I can still find hair in that same twist. You can still pull out of it 5 years later. So that's something to notice or to note as well. So we think it's real temporary. Hair's pretty, very, very durable material. When they do these twists and get it in there deep, it's plugged in so tight that it just won't wash away with nature. This one was actually pretty fresh when we found it. It was about 2 weeks. They had broken down the top about 2 weeks before. Another type of structure we see in foliage manipulation are sunshades or shelters. So some shelters, they'll make in the forest and it's apparent to get out of wind or do it out of wherever. In this situation, they've taken the mass of material and just made an impromptu sunshade, because in this region, you have a very desert, very arid regions, occasionally gets extremely hot. It's interesting because this was found in a travel zone where there hardly is no cover, that it's between what they call bosky regions, or the treed foliage regions within the river system. So as they move between A and B, they're completely exposed. and they're exposed to the elements of the weather or whatever, and they'll do things like this, where they'll make basically what I'd consider a temporary sunshade or shelter. They can just escape the elements while they're there. It's also a pretty good hide. From above, you wouldn't be able to necessarily see a subject beneath this mask. Now that's going to take us out of foliage marking and foliage manipulation and into defecation. So studying the scat, the habits of scat placement, the type of scat things is extremely important. It can often give you more data than anything else. Because let's say, for instance, you find scat from a subject with 17-inch feet, and that scat contains elements of material from something not in the riverbed system. Yet no other subject, either with a smaller foot or maybe the inferred female, ever has that material. What we can glean from that is that the individual or individuals of that size leave the riverbed area and raid feeders, raid farms, and things like that, because he's getting a wild bird feed mix from somewhere. So we can identify the wild bird feeder mix. Now, if we wanted to, we could go to the surrounding neighbors and find, it might be a couple miles away, whatever, it's real rural, but we could actually go find who's putting bird seed out, what bird seed mix there is, compare that to the scat, and we know which subject's been visiting there, and thus we also know where that subject's been going. And so this is direct evidence. There had to be a way the bird seed from a farm or ranch gets into the scat that's into the river basin, when there's no bird seed or anything that's been brought to the river area. So defecation becomes an extremely important indicator. Extremely important. Learning how to find it's very important. So what we're going to see first is how to find it. So they will generally go either on an open water course area, or they will go behind thick foliage up against an obstruction, so where one of their routes or one of their accesses is blocked. And then they'll go up against that obstruction in a hollow area behind thick foliage, and they'll all defecate together in a group. If they're in a group, they'll defecate solitary course. But what they'll do is they'll do it as a group at the same time. And as you can see here in both examples, lower left and the other photo, is scat piles are placed pretty close to each other. Now in the group that we're tracking, there's at least 7 individuals, and we'll find 7 scat piles. One will generally be 20 to 30 feet from the others, and we assume that's a watcher. He's watching as the others defecate, then he defecates, and they move on. This is what it apparently appears to be, because they'll all be grouped together except him. Either that or he's an outcast when they all go collectively defecate. And what you'll notice in the right-hand photo, again, is there's 2 tracks there. Actually, there's an entire trackway and a dragway where she was dragging something too, but that's the alpha female's track. So, and then in the scat pile on the top, you'll also see right in front of Bob's boot, there's a print, and then just to the left of the circle, there's another print, and that's from the other smaller subject. And so you've got the 2 scat piles from the 2 subjects that were cruising together, put together and placed just like always. And those 2 tracks are 20 inches apiece, and we can look at the step gap, heel to heel at 1, 2, 3, 4.5 feet. This is a step gap on the female. And she's not running. You can see the pad. She's got a lot of mud stuck on her feet. She's leaving a very, very padded looking footstep because her feet are coated in this clay. So that's going to bring us to the contents, the next part of the story that tells us an awful lot. So when you look at the feces and fecal material, it's an omnivore, so you'd expect to find omnivorous feeding behavior shown in the scat. Now, to show that they eat the juniper berries, the scat on the left is comprised primarily, as far as its particles, of juniper berry seeds, which shows they've been eating the juniper berries as a food source. It also contains fur and the remnants of quite a bit of plant material. As far as contents in a great example go, we've got the one on the picture on the right, and I'll just list it down. We've got a grasshopper leg, deer fur, a rodent bone, Indian pine nut, and Russian olive seed, all in the same scat. This shows diverse foraging for vegetable matter, seeds, foraging for insects, foraging for small rodents, all in the same defecation. So this was all between meal to meal. This was one feeding represented this much forage. What's important to note is pinyon pine nuts are not available within about 5 miles of this region. So this also tells us this subject left the region and on its path encountered these things as it did and ate before it came back home. So this is directly inferred through the evidence. It's not assumption because there's pine nuts in the scat and no pine nuts available at the location. So this is going to take us out of ecology and we're going to step into behavior. Now the reason this photo is up on the screen, this is a real photo. The bottom center is the actual picture. It was taken from almost a mile away with a 70mm lens and a Sony SLR camera. Now when we crested a bluff or a large rock butte at 1 mile, or close, 3/4 of a mile, she picked up a 7-foot smaller subject and carried it away like a toddler. And in this picture is the second frame after she grabbed him and rose up onto her feet bipedally. Now on the right side of that photo, you'll see the actual raw image, and you can make out her, and she's facing kind of away the other direction, and you can make out 2 reddish appendages coming around her neck. And where her arm would be, you see the feet. And where her head is, you see also the head of George, the smaller, looking out around her up at us. But we're 3/4 of a mile away and just crested. And that was how responsive they were to our presence. A deer, you can watch a deer for 3/4 of a mile. You can watch a bear for 3/4 of a mile, watch a mountain lion for 3/4 of a mile. None of them will just bolt and panic and blow from you at that range. But she, at 3/4 to a mile, noticed us and was gone. I mean, gone. And we had just seconds. I got about 4 frames of her, and we had just seconds it took to get her to disappear. So we immediately went and got transit, a stick, and went down and surveyed it to see just exactly her size, because she left 20-inch or 19.5, 20 inches. It's hard to tell sometimes where the edges are because her feet are so flexible. We average about 20-inch tracks down there. And there was also 13 to 14-inch tracks of George at that time. So we ID'd it through tracks both of the subjects we now can see in the picture. So what we did was we did survey techniques, and we estimated her height initially to be about 9 foot. Well, once we actually physically measured it and scaled her using advanced techniques, she came up to be 10 foot, and if you look, she's slightly crouched. So if she went to really stretch and be fully erect, I don't know how tall she'd be, maybe 10'6", maybe a little more, which is considerable, but that gives us a good scale because we've got her feet, and well, we have her survey scaled with good techniques. So you'll also notice the guy standing on the ground in these photos gives you a representation of what her scale would actually be. Now this is, I'm not exaggerating, and this is as accurate as we could possibly do it with survey equipment, right to the inch. And he should be scaled to the proper size next to her. Now people want to say, well, maybe that was a guy in a suit. You could put 6 people in the suit. You could put 2 people in each leg. You know, this is massive, and it fits her 20-inch feet. So we have a consistency, a reality in consistency. We find 20-inch tracks, and we're able to photograph a subject like this. It's like the Patty thing. Oh, we got prints, we got the whole thing. Well, but it validates that course. Now I'm going to go into something else. I think we might have all, or most of us, heard we talk about the hair and the color of the hair. Okay, most people don't really realize it started to come out. Oh, they have purple. There's purple to their hair. I don't know if any of you heard this or not. The people who are saying this, they're getting it right, but they don't even understand what that means. Say, sure, you can backlight the hair and it emits a very purple hue. But what we do is we map the light frequency, not just the visible color. So by using a vector scope, takes color from a 2D side view as a wavelength and aims it at you, and where that wavelength tilts to the side, okay, you can map the 3-dimensional nature of that color frequency. So the light refraction is visible color and a secondary color coming from the structure of the hair itself. And that tends to be in this purplish hue. So the top left photo here, that color is the actual representative color of the light FQ, the refraction. That's like when you use polarizing light or a microscope to look at the refraction off of it. It's basically the same thing. So we were able to use this as a vector filter to test images. And if it's a Bigfoot, you'll notice that George is if you look at the one picture on the right, she's nearly black or dark gray, and George has a reddish tinge. But on the left, they both show up in the vector filter because they both contain that frequency refraction. So we're able to look at a photo and say, oh, well, that's a Bigfoot, that's not a Bigfoot. Well, we throw it through a vector scope, put this design, it's a design filter we design, apply that to it, and it'll either show up or it won't. If it's not, if it's a stump or a rock or anything like that, it just won't show up. In other words, she'll be the only thing, or almost the only thing in the entire frame that shows up once you apply these filters. So it's a great way to validate what we're looking at is through this unseen spectrum of light, and that tends to go into this purple hue. Now, the first thing in behavior is, I think you guys will like this probably, is vocalizations. So we're going to run into a couple of different examples here, and some of these I hope that they're not the common. We have a little over 100 hours of recorded vocals, everything you can imagine. But what I chose to show you this evening was what I hope a lot of you have not heard before. There's a couple standard howls here, but there's also some other stuff. So in this first sequence, you're going to hear a mountain lion react to the male when the male is coming back in to join the family unit. What we do is we'll pick up an additional sound report for him approaching the riverbed off of the mountain. And then we'll use our directional equipment and we will track him as he makes his vocal calls 4 or 5 miles all the way till he gets down to where the family unit is, at which time he'll stop. And we also tend to try to map the responses. And what you'll get is this real blatant howling, long sessions of howls, because he's not intimidated and he's on the move. But the family unit, mainly being the large female, will often respond, but in a nature that won't give up her position unless you're moving and can triangulate it. So she'll do a single grunt, or a single bang, a single knock, or something, a single sound, and she will shut up and not make another noise for quite some time. And he'll get closer and closer, then she'll respond once again. And you can see through, we've done this dozens of times, so we're watching the individual move down the system through the sound. Okay, so doing this, on this one, I want you to note the human traits of this. So most of these are at such great range. We're recording audio at this time with a 22-inch parabolic dish, 22 feet off the ground on a mobile laboratory. And so we're listening 2-3 miles is where we listen to get a lot of this stuff. But even at that rate, unfiltered, hear the man quality of this howl. A lot of them we lose this because it goes so tonal because we have to elevate and amplify it. But this is pretty raw. So I'll go ahead and play. Okay, and there you go. So you heard this long man-like yell, and then he drops to a lower octave. And so this subject commonly screams right about 800 hertz. Sometimes a little lower, whatever, but he always has the same drop-off nature. Each subject has a little different howl. So you can catch this, and you can start to ID them by the structure of this howl and how long the initial howl, how long the drop part of the howl is, and everything else. And then, of course, you see a mountain lion somewhere within that 2 to 3 mile range that we're gaining this audio. There's a mountain lion that responds during that call. So this is an isolated howl. So this is one after it's been through a full filter gamut, and we've removed every other sound except the howl itself. And we do that with 3D sound mapping. So it's going to sound a little mechanical and a little over-filtered, but we do this because we're trying to study the tone. We're trying to study the size of the animal that's making the sound. And you can see how clean that is in reality once we apply the sound filters to it. Now this is something similar. It's a little less filtered, but what we have here is where a couple of individuals howl. You'll have one howl and you'll have one join into the howl. So on a spectrum analyzer, you're looking at 4 different subjects. So you're looking at a subject howl, and then one joins in a little higher, and they all dive down. And so this is the male howling from one direction, and the other harmonic response is coming from the direction in which he's headed to. And they'll join in this, in anticipation. So here's another one that's a little more complex. Okay, so you can see how the relationship there goes with the initial howl and then the response and chime in by the other. So it's almost a way of touching base with the subject doing the initial howl. You're responding, but you're cooperating and you're joining in this. So it's a way to make contact, we assume, with the subject. So now we're going to do a howl and a whoop. And so that shows again just a howl and another subject kind of doing a whoop in the middle of the howl. Now I want to play for you something that we tried to hook up better bass system in here for this recording. So we know that they can produce very, very low frequency sounds, and these low frequency sounds can travel a lot greater distance than the higher frequency sounds. And I've also heard about infrasound and things, and it's become popularized like it's some magical ability. I can produce infrasound right now. We all produce infrasound at times. The fans and the heaters produce infrasound. That just means any sound under human hearing, which is nothing that special. Okay, it's just anything under 20 hertz. We often, the recording equipment we use register from 0 hertz up to 20,000 generally. What we see in the lower left photo there is a single infrasonic hit. So, and that felt like getting hit by a rolled up, I always say it's like an 8-foot roll of carpet. And someone swing it like a baseball bat and hit you as hard as they can. And that's what it felt like when I got hit by that blast. Now, using this subtonal charge, I would say, is a way to communicate long distance. It's also a hell of an intimidation factor. And what I tried to get across during this recording to you guys was I wanted this to feel the way it feels in the field. But none of this system can generate the type of bass hits. Now, if we had one of these cars that are driving around thumping rap, that would do it. If we had big PA, it would rock your world. But we're going to give you the best we can with these little bitty speakers out of the ceiling and trying to produce this tone. Okay, so we can see that most of our amplitude is in a lower range that's too low for these speakers to be able to play. So when you hear this type of thing in person, it literally reverberates your chest. It makes it hard to breathe because your chest is vibrating. The next one will as well will be a good addition to that. So you can hear the reverberation of these little speakers distorting, trying to generate that tone. So this is very long range. It's been cleaned up a little so we could hear it, but this is one of the only aggressive screams we were able to capture and bring to you. So what you're seeing is initial scream and roar, and you're hearing sound as it's reflecting and absorbing and bouncing to us from the mountains and things like that. You end up with a slight echo. Now this is probably the longest overall single howl we've ever been able to record, but when generating a massive amount of amplitude at a full yell, imagine trying to sustain this note, expressing your full volume. So that's carrying a note that long. We could try it. I haven't found anybody that could actually expel mass volume that's been able to carry anything that long. And so I think that was probably one of my favorites as far as impressive. Once you've heard a whole lot of these, you just don't hear them carrying tones that long. I think let's see how long we're gonna go here. So I think we're gonna push long. So the howl sequence, is anybody in a hurry to leave? Because the howl sequence is 3.5 minutes. Do you guys wanna hear it? Now this. Now this is a filtered sequence, so. Now this is about 5 degrees that night, so that was not a frog. And you'll notice it changed each
Okay, the
time.
Bigfoots are howling. It's 8:52 a.m. I'm now plugging in the large parabolic mic on the track.
Yeah, so they'll do mimics, and they're close, and that would have been a leopard frog, although they altered it. It's not the frequency of a leopard frog, and they changed their octave as they repeated it.
So it's Wednesday, 1/9/2013.
I have no idea how they did it. Something also to pay attention to is the amplitude change. So occasionally he'll be yelling and yell right toward the bush, and it'll just peak and distort.
Okay, it's been 30 minutes. We're close to 29. I'm going to reset this and start another take. Same thing. Yeah, 9 minutes after 8. January 09.
Okay, so that's going to conclude our audio. So I hope you guys enjoyed that component. Next thing we're going to get into in behavior is foraging. So in foraging, the first thing is they move as a scattered group searching for individual and group food resources. So as they move through an area of foraging, they'll often separate between 30, 50, or even up to 100 feet from each other, and they'll kind of comb through the environment. And they do this for the same reason that turkeys do it. So if you watch wild turkeys, they'll form a line, and it's like a search party looking for somebody. So they'll space themselves out, and they'll just cross an open area. And the best thing to do is you can forage at the same time you run a likelihood of flushing. So on flushing, you can do responsive hunting, responsive kill while you're foraging for your material. The next thing is gathering and consuming food while searching without collection.
So they'll actually gather and consume food while they're going and not be collecting it as they go. As such, we look at a lot of native cultures and things like that. Even though they will collect resources and return them to camp for sedentary individuals, which we'll also discuss. So when you have an elderly individual or you have an injured individual, you have something like that, and with the family unit, we often see evidence declaring this. You'll have them removing and bringing in things that they can carry to be consumed by the individuals that are stuck at the habitation. We don't very often, see any evidence of the larger independent males, not the big alpha males, but the larger independent males, bringing hunts and game and things back to the group. You'd suppose they would do it. I would assume they would do it, but we have not really seen much evidence of that. Using top methods. So this is where culture comes in. Do they have a culture? Are they human? Are they monkeys? What are they? So culture is one thing that defines humans as humans. It's not just their bipedalism or their diet or their structure or morphology, it's also that we adopted culture. So using a top method, a plant animal, the hatch times, migration times, and stages is something that we would call culture. The only way to learn these things is not through a single lifetime, but through repetition over generations. Because in a single lifetime, they're not going to be able to identify enough information to be able to predict, let's say, a gypsy moth hatch out, or where the grubs would be at a certain time or stage of the year. These things change annually based on weather changes and things. Yet they can predict this and be extremely, extremely productive in harvesting these food resources based on this information, which leads us to believe there's culture and teaching involved. They also search as an individual subject. So the younger males and even let's say George's age, where he's maybe a young teenager, will also just kind of rambunctiously cruise through, hunt and feed all by themselves as well, without the group. That takes us into hunting. So they use cooperative hunting techniques for small and large game. Now, there's a couple ways they do this. Usually it's by herd behavior where they'll run, I wouldn't say, when you say run an animal down a mountain, it doesn't mean you make the animal run, it just means we direct where he travels by slowly making noises, having a presence, and pushing him slowly downhill. One of the ways they do this is they'll set up an ambush position downhill. It'll usually be at a pinch point, maybe where you've got a ravine, so you're on a finger of a hill or something, and then you'll push them over and down into the ravine section near the bottom. These are common ambush locations. Also, when we do research in the field, we know to avoid those particular spots because there's often a subject in those spots waiting to ambush prey that comes about. And that can get pretty daunting if they react to you and try to intimidate you. So we see cooperative hunting as well, where they will again, they'll run them into another subject, but it won't necessarily be in a pinch point. So you may have 2 or 3 subjects lower on a mountain slope or on a side, all of them at the base, and then in that way they don't have to move to try to meet deer. So if you don't have a convenient draw or ditch or low spot or something to try to funnel the animals into, let's say it's a big broad slope, they'll park 1 or 2 subjects or 3 subjects at the bottom at strategic locations, and then they'll just vaguely run game down off the hill to those subjects. Okay, so they will funnel and direct deer into ambush positions by using foliage barriers. So we've also noticed that, and quite a bit of repetition, so you'll be moving around on a mountain and you'll see gaps in, let's say, cedar trees or pine trees or whatever. And you'll notice that for some reason, there's some small foliage markers and what some people call structure, whatever, and they'll be laying maybe across an open gap. And you'll see this kind of angling maybe down a slide of a slope. Well, what's happening here is if you take, let's say you took a garden hose and laid it on an open bank of the hill, then a deer walked down it on its own, on its own even. So the deer won't generally step over the hose. It's just their nature. They'll go along it until they find a break in it. And I don't know why they do that. We don't see that well in the dark, however it is, but they don't want to step over the line, so to speak. So if you want to direct their movement, all you have to do is lay branches, lay logs and things on the ground, and if there's an easier way for them to encounter it and cruise by them, they will choose that way before they go over it. So in this way, it's a passive way of cooperative funneling deer into certain locations on a mountain. Now, this was a little bit different. They funnel and direct deer actively with presence and vocal reports. And that's what I mentioned before. So when they would get subjects above, and they're going to do when I say actively, it's in some ways it's kind of passive, where you're just kind of making little noises and you're just kind of pushing vaguely. And other times they'll actually make pretty good sounds, bang huge rocks together, do a hellacious growl or a gurgling howl or something like that, and the animals will react and try to flee right into ambush positions. And they construct and utilize sound traps to locate both prey and danger. So what I mean by sound trap is you'll be on a trail system or something where you can't move to either side, where you're very well stuck to one position on this trail, so you can't get anywhere without making a ton of racket, let's say. So our frustrating part is we've experienced these while we're trying to sneak up on the individual, so it's not easy to do. I'm sure all of you know this. So what we'll encounter is on the ground, you'll have a crosshatch pattern of laid out sticks, maybe 1 to 2 inches in diameter, that are laid across trail and then lengthwise with the trail. And there'll be 2 or 3 layers of these laid in and loosely. And then they'll take leaves, even if there's no leaves on the trail, and they'll dump them in amongst these sticks. And they'll do it 8 or 10 feet long. So there's no way to jump over them. And there you have it. So the only way to continue forward is to make a ton of noise, and you know it. And they're pretty apparent once you see them that this has been constructed. And we believe this is in 2 forms. One is to alert them to any movement that may be coming into their situation. Another is to alert them of any game that be moving through the situation and actively hunting them so they can see where about the trail it's going to be. So a deer could jump over it, but generally a deer will just soft walk through those branches, and which keeps them in kind of control and make those leaf sounds. So they'll also build rodent and small game traps, stashed as nesting sites. So they'll take chunks of pieces of hollow logs and things like that, and they'll place them in open zones near food resources. And we've seen this repetitively. And then often they'll take grasses and things and kind of stuff them in there, and then they'll put them open side down. So they might stand that log piece up on its end. And what we found after time is you can go and lay those down, and rodents get in there and nest. And it makes it a really easy, it's like a trap. It's like they catch octopus, with jars. You throw jars, you throw it on the open plain, the octopus seek those shelters, and then you can pull them up. It won't work in rocky areas because they'll use the rock for cover. This is similar. They'll take an open area into a food source where it's more convenient to use this thing that they put there than is anything else, and they'll make good shelter. And that way you can just kind of flip it and collect. Flip it back, and you wait 2 or 3 weeks, flip it and collect again. So our next part of our behavior is occupation. They normally utilize an area about 2 square miles for a 5 to 7 day period as a family group. So this is what we've seen. I imagine it changes regionally because of resource depletion and effect on the habitat. So they can't stay in an area very, very long as a family unit and not have detrimental effects to the environment, be it the animals or be it the water or be it nature itself. So they'll often occupy a zone, and that zone that we found is about 2 square miles. And then they will occupy that for a number of days, where we're researching that's going to be about like I said, a 5 to 7 day period, and then they'll move on. And they won't generally move on to the next adjacent piece. They'll normally go a mile or 2 or 3 from that position. And I believe that's because when you've affected the game in this location, you're going to affect the game in the next location as well. They utilize an overall range of approximately 100 square miles as a family group. So you're talking 10 miles by 10 miles or in a linear fashion based on the topography. But as we see, they can year-round, if there's subsistence food like the Russian olive and the cedar and wild berries and the yucca and the things that are there year-round, they can comfortably make it in about 100 square miles is what we figured that they require. They change the area as the resources diminish to non-adjacent. So like I said, they will, as these resources diminish, they'll begin to move, and they'll often do it in an area to where they have not affected it yet. They alter the overall range due to seasonal weather and or game migration. So they will do things like follow the herds in elevation. So in the wintertime, all the deer and all the animals move farther down the mountain. So you're going to find them in this range to maybe just below slow line. That's where most of your evidence is going to occur because they're going to be in there with that game. As the snow retreats to the higher elevations, you'll see them move up along with that snow line, chasing the weather. And as well, the game migration is largely due to the weather, but you'll also find, like I mentioned before, when you have hatch outs, you might have a rodent season where you have a rodent hatch out or whatever in a certain location area, and they'll actually change the family unit's position based on that resource. utilize high rugged areas for retreat, solitary, group, larger males. So this is something that as well we'll get into grouping, and the larger males we've seen often won't stay around the family units, and the young adults won't stay around them. So they tend to retreat to positions. Now we've seen this with native tribes around the world as well of humans. Oftentimes the elder men of the tribe will stay almost just to themselves and not really encounter with the day-to-day lives of the group and all these things, because they're generally not with necessarily with Bigfoot, with humans. They're in spiritual, they're in medicine and things like this that take this inherent knowledge that they glean, and they'll hold that and they'll be their function within the group. And you won't often see a lot of younger males that want to hang out with the old guys, and you won't want to see the younger males want to hang out with the family group anymore. So we end up with younger males kind of in between that region. And that takes us to grouping. So within the grouping, they form family units of what we've seen and studied, 7 plus or minus subjects, female as lead, and male mostly absent. So like I said, the male will usually go and hang out in eye mounts by themselves, whatever, but what the key thing here is the female apparently is left in charge, or is in charge, like a matriarchal situation, until he returns. And so she really doesn't have a choice. She's with the family unit. He bolts, she's in charge. They'll form large subgroups of young to hunt and forage for the unit, often cause trouble. So when we have the younger teenager individuals in that size range, they'll often group together in pretty large groups. It gets surprising. You might have 7, 8, or 10 individuals from different family units that will cluster, and then they'll go raid, and they'll chase stuff, and they'll make noise, and they'll tease people, and they'll mess with things. They get pretty cantankerous. So it seems like that several family groups, the teenagers, let's say to speak, and it seems common even for humans, will leave, gather together on their own, type of sort of thing. But it's not on a permanent basis. They'll just do this and run, and they'll separate again. Form smaller subgroups of 2 to 3 older subjects to hunt for large game and raid. Now this is what we see when they get anywhere from 14 to 18, 19 inches up in that area. They'll often get together in small groups of a couple individuals, probably because it's more serious hunting technique if you really want to procure game. And then they'll go out and hunt and get food. Now we have seen those small groups return, apparently, food back to the family group. Males often move a few miles away alone when young, fully mature. So, like as I said, we'll have these males go away from the family group. They don't want to hang out with the family, but they're not fully adult males. They don't feel comfortable with the elders. So they'll go find their own kind of little hillside, or their own canyon, or their own little mountain, and they'll hang out there either 1 or 2 or solitary. And so this might be maybe in the late 20s or something like that, when they're just specking out on their own. And we see them returning to the family group maybe once a week or once every couple of weeks, until their foot size reaches 18 inches, 17, 18, 19 inches, something like that. And then they rarely return back to the group. And we assume this is when they're going to mature out to enough to at least maybe even move on. Large males will often retreat to the highest rugged, dense areas altogether. So this is one thing we have seen. So in the Sandia Mountains, we saw evidence up there that was so large and so intimidating that 6 military vets, half of them combat vets, got so scared they didn't even stop to take a picture. And it's because the gravity of what we witnessed in an area where these males joined together. We witnessed an area of about a quarter mile square where they had removed every green bough off every pine tree up to about 60 feet. And they had removed every bit of green foliage off the forest floor, and they had carried in, not pushed over, trees up to 100 foot in length, 3-foot bases with the root balls intact, and brought them in so dense that you could not walk in any direction whatsoever without climbing over them or going under them. And so packed, so tight, you couldn't barely see. And in this particular spot, the Forest Service had attempted a trail through there, and they chainsaw it out all the time, and they just pile it. So 13 in one night is what one of the cutters told us. So they had to cut out 13 trees in one night where they blocked them out. And they told us a region that looked, in one place, there was 2 trees on the side of the trail, and they had stacked them up in between the 2 trees, and each time a guy cut it, they threw another one in there. And it was 7 high. So you're walking next to it literally just a cut 7 trees right on top of each other, stuck in these trees where they had tried to bridge the trail. And then we progressed a little bit farther. They had taken a 120 foot tree, 3-foot diameter, 12 foot across the root base, rocks, roots, and all, and put the entire root ball directly in the trail. So you've got a 12-foot tall, 8-foot wide root and rock and dirt obstruction connected to a 120-foot tree and blocking the trail. And they had to use chainsaws again to cut their way around that one. Okay, now we're gonna go out of this and to our final few questions here. I want to talk about a little bit about the DNA. I'm going to bring this up because I was asked about it an awful lot, and people don't understand what happened. And there are others that need to have these questions posed to them, and I'm not trying to start any crap with them, I'm not trying to call anybody out, but what people need to do if they want to figure out where the good DNA evidence is going, these are the people you need to ask, and I'll tell you why. We were approached by the Oxford, Louisiana Collateral Helmet Project, and as I told you, they waited 2 months for this study for us to grant them this sample, 25076. This sample was collected under all types of witness by camera. It was transferred in a hermetic chamber under positive pressure. There was absolutely zero transfer contamination. It was accompanied by the large 23-inch track you saw, handprints, 170 footprints, and evidence of bite marks and collective hunting. So all these things came with it. It was collected in the presence of U.S. Forest Service personnel and an anthropologist and 6 other people that were there that day. So there was no arguing. If there was any evidence collected that had a trace of custody that was bulletproof, this is it. They waited 2 months for this study. They held the entire study. The whole world waited in anticipation for their results. They were waiting on us during that 2 months. When we gave them that sample, and I didn't hear a word back from Brian. Now, it took another 2 months before they released the data, but when they did, I got pretty upset because I know what this hair is. There's not a question in our mind whatsoever. We have all the corroborating evidence. They stated that they had tested every single sample for DNA, and some of it came back with a possum, some of it came back canine, some of it came back what they called a hybrid polar bear between an extinct species and the modern species. And that's what they believe the Yeti was being seen. The first question you need to ask anytime you see a DNA study is why in the hell did you even DNA test a hair from a bear? Why did you DNA test a hair from a possum? And these are the things they came up with. Why did they run them? So every single hair that's out there has a morphology to it. This morphology is easily readable based on scale structure and a few other indeterminating factors. Now, scale structure especially, we see a lot of things about, the medulla. That's because most of you don't have microscopes that are capable of checking and validating what you're being told. So we knew what this slide was, and when they didn't release it, and they told the AP that they had checked every single hair that was submitted, and that they had not found any anomalous readings, everything had been identified. So our conclusion was, for one, you're not that incompetent. You're the Museum of Zoology in Lausanne, Switzerland, the absolute best at this in the world, species identification. Why did they ever DNA test it? Every hair was qualified. That means you check to see what it is. And the only thing you're going to DNA test is what's unknown. You're not going to test a bear hair, a known bear hair, for Bigfoot DNA. How oxymoronic would that be? Okay, so nothing, if they didn't find anything unknown, which they claim, nothing should have been tested. They should have had no test results whatsoever because everything was a known species. Now, this is interesting. Our first submission came back unrecoverable DNA because it was a broken hair shaft, no follicle. There was no medulla, it was chestnut brown, and it came back unknown, period. So they didn't test it. Now, this is interesting. So why did they test the rest? See, we see real results coming back to us in letters, but we see hoopla, fake whatever, that the mainstream people will believe being released to the AP. The most interesting part is the letter that I have, which directly contradicts what was released to the Associated Press, which states that our sample was never tested. Now, this is interesting. They held the study for 2 solid months. There was nobody provided anything with any more corroborating evidence or evidence of custody and trace of custody that showed no contamination. Yet they didn't test a sample. Why would you hold a study for 2 months and then not test it? Because it's too good. Something happened. Now, interesting to us is was when they released the news to the Associated Press to the world about this big project and their results, they claimed every sample was checked, qualified, and tested. No, they didn't. This sample, 25076, anybody's welcome to contact Brian Sykes at Oxford University They ask him, where the hell is that sample, Brian? Where? Everybody knows with DNA, time is an important factor. DNA ages and it oxidizes. This hair had a hydrated follicle, meaning it was on the animal less than 50, on a hot day, less than 15 minutes before its collection. It's extremely important. That goes directly to a lab to get tested, not wait till it dehydrates or anything else, because this degrades and oxidizes DNA. So why in the world would they curate the golden boy of the sample, the smoking gun sample? Why would they curate it at the Museum of Zoology in Lausanne, Switzerland for potential for future study? This needs to be asked, and we need to ask Brian Sykes about this. The next one's going to contain a very familiar name. As I said, I'm not here to throw rocks at anybody. I'm not here to start a war. But this person needs to be asked about this. This is the UNM Gallup, University of Mexico, year-long field study in which we returned a lot of samples. Good ones, and I mean really good ones, from eyewitness episodes. We know the creatures by eyewitness testimony, what they were that left them behind. These aren't hairs we found without seeing an individual. We're talking hairs with tracks. Some of them come with food remnant material and everything else, with the witness seeing the subject and us collecting the hair from like a sapling that the witness saw them run over. Now these hairs are tremendous. They showed morphology that the head of UNM biology department, when he came and saw them, when I had to fight news, KRQE News, because them and the state tried to accuse us of stealing from the taxpayers, and the state senator even proposed law to block our research into mythical animals, which every animal is mythical till you study it. So, but regardless, it went to that type of scale, and so we had to deliver a package to a scientific peer group to fight those conclusions. The point being is this, is we didn't have any DNA to show them, and they bragged about the fact that, okay, if you guys did this study, and they're on a special investigative report for KRQE News, 22 minutes long, and they say, well, there's nothing showed from the study, so you guys ripped off the taxpayer, proposing that you're studying a mythical creature, which gave them legal action. They were going after the executive director of the university, named Mr. Christensen. So, on this point, they will go to such an extent to try to jump on something and to defame it and to tear it down. Now, the reason we didn't have these samples, this is interesting because I still have a copy of every sample that went in. I have a little bit of all of it, so they can't say it didn't exist. We have the head of the biology department at the University of New Mexico, who have some of the best primatology schooling there is. They have gorillas in the zoo. They do all this. Tara was a part of that program for a while. This man looked at the hair on the bench with the microscopes that they're provided for him and said, I've never seen anything like this before. In any species, and this is about a 6-inch tapered hair. It had some really off-the-wall characteristics and everything. You know, we still have them. So the point being is, we gave these samples to Dr. Meldrum, okay? Now, after he received the samples, we didn't get word back from him because we needed trace of custody. That's normal science works. If there's a record of that, that's your chain of custody. We asked for chain of custody. Where did the sample go? The sample, he said, well, actually, he didn't return a call for a year to the executive director. This is just a fact. I'm not putting anybody down. And after that year, we were having a conference and presentation for the faculty and staff to deliver the results of this year-long field study, at which we did. Highest attended, over double the highest attended function the university had put forth in 47 years. That's how much interest there was. When we laid out tons of evidence and things, and this is what we were doing during this, but the morning of the event, since we had hired Dr. Meldrum to come speak. Now, as soon as we called in and offered a money deal, he showed up and wanted to come speak. So cool, now we got him. So when we got him back to college, the executive director, Christopher Dyer, Mr. Dyer asked him at the table in the hotel that morning, put him on the spot, said, I want to know what happened to the samples. Where'd they go? We gave them to you 8 or 9 months ago. Where are they at? And he just shook his head when he was eating his food and said, I don't know. Now, this is the scientist, PhD, okay? You learn this stuff in 7th grade science. They're much more careful than this. He knows better than that. I mean, absolutely. What do you mean, I don't know? This is a university study. We just handed you 8 samples that were supposed to go to domestic laboratories to get studied. He was instructed overall, do not go to overseas and do not give them to Brian Sykes. So he's sitting there chewing his food, and we're asking him again, no, Jeff, this is a real deal. You know, the executive director of the university asked him, I need to know where they're at. So if you lost them, I need to know you lost them. If you gave them somebody, you need to know that. He said, oh, well, I gave them to Brian Sykes. There we go. There was the end of it. No one knows the samples. Where did they go? This needs to be asked of Dr. Meldrum. Where are the samples? Because he was in charge of his custody. He's responsible, not who he gave them to. He needs to figure it out. This is about as lame and unprofessional as anything I've ever heard of in my entire life. I can't imagine anything like that. But these are the questions that need to be posed to the people that are leading us through this. And I'm going to tell you why. And that'll wrap up our presentation with this slide. Ape versus man. What's going on here? We have the very same PhD anthropological scientist professes to be a master in locomotion and the understanding of these primates. Okay, there's a unique factor here. And I'm not saying so either way, but I'm just going to tell you what's declared. Well, by the evidence, what's declared is we're working with a tribe here, a tribe of some form of human. That's just what the field evidence declares after 10 years. It's not a monkey, it's not an ape. But it's interesting, because how do we believe science sees this species? We believe science sees it as maybe Gigantopithecus or some other form of ancient ape that has managed to survive to this day, a relic great ape. This is one form of thought, okay? But it's interesting, when you look at modern anthropological science, what dictates a human versus any form of ape? We're both primates. But there's only one primate of the 500 known types. There's only one that's bipedal, period. It shows up in no other primate, period, in any form, only humans. So if you have a primate, by definition, and it's bipedal, it's a human. So what the quote I'm going to give you right now comes directly through the modern anthropological curriculum. Tara's now studying this, taking it to school. This is directly from her textbook. We have it here. They've got an entire page dedicated to Bigfoot. Now, we're all of the belief that, well, they don't do that. They would never do that. Academia scoffs at the thought of Bigfoot. You want to know? I'm going to tell you the truth. No, they don't. They don't think they're apes. This is being perpetuated to you by the pros in the field to lead you down an avenue, whether it is ego-based, agenda-based, or for whatever reason, it doesn't matter. I'm going to tell you, this is how it really goes right here.